When liquids act like solids, exploring the states of matter. Matter is everything around us that makes up our physical world. Scientists say matter is anything that has mass and takes up space. It includes you and everything you can see and touch. Mass measures how much matter is in an object. For example, a bowling ball has more mass than a basketball. Volume measures how much space an object takes up. A bowling ball and a basketball take up about the same amount of space, or volume. These differences in properties happen because the objects contain different types of matter. The building blocks of matter are called atoms. Atoms join together to make molecules. Groups of molecules make up everything you can see and touch. Temperature affects how atoms and molecules move and spread apart. When the temperature increases, molecules move faster and spread farther apart. When the temperature decreases, molecules slow down and come closer together. The way molecules move and how far apart they are determine the matter's state. There are 5 states of matter: Bose-Einstein condensates, solids, liquids, gases, and plasmas. Each state has its own properties. On Earth, you will see solids, liquids, gases, and plasmas in lightning. You observe matter changing its state when it freezes, melts, condenses, or evaporates. Solid matter is cooler than its liquid or gas state. Its molecules are packed closely together and only vibrate in place. Solids keep their shape. A liquid's properties lie between a solid and a gas. The molecules are close together, but they move around each other. Liquids flow and take the shape of their container. Both solids and liquids have a definite volume, which means they take up an exact amount of space. Gas molecules move quickly in random directions, but they are usually not visible. Gases spread out and fill all the space in their container. If there is no lid, gases will escape and fill the space around them. Can matter act like a solid and a liquid at the same time? When scientists observe a liquid, they describe its viscosity. Viscosity is a measure of how thick or runny a liquid is. It tells us how easily a liquid flows. There are 2 types of liquids: Newtonian fluids and non-Newtonian fluids. Most liquids are Newtonian fluids. How they flow depends on temperature. For example, warm syrup flows faster than cold syrup. Temperature affects how fast the molecules move. Higher temperatures cause molecules to flow faster. Lower temperatures cause molecules to flow more slowly. Non-Newtonian fluids are special. Their viscosity also depends on the strength and type of force applied. They can act like a liquid or a solid depending on how you pull, push, or shake them. Slime is a non-Newtonian fluid. Pulling slowly stretches the slime. When it sits on a table, gravity's weak force slowly spreads the slime like a liquid. A quick pull breaks or splits the slime in half. When you drop slime, the strong force makes it act more like a solid. It hits the ground with a slap and may even bounce. A true liquid would splatter and spread out on the floor. Another example is cornstarch mixed with water. This mixture is called Oobleck. When you hold Oobleck in your hand, it flows between your fingers like a liquid. If you hit Oobleck, it feels hard like a solid. Some have even filled kiddie swimming pools with Oobleck for fun. You can run across it if you move fast enough. If you stop, it acts like a liquid, and your feet sink in. Because slime and Oobleck can act like liquids and solids, they are fun to play with. Silly putty is another example. Not all non-Newtonian fluids get thicker with increased force. Some do the opposite. Did you know ketchup is a non-Newtonian fluid? When you tip the bottle, the ketchup may stay stuck. Shaking or squeezing the bottle makes the ketchup flow more easily and act more like a liquid. In this case, more force decreases the viscosity or thickness. Honey acts the same way. When you stir honey, it becomes runnier and flows more easily. An increase in force decreased the honey's viscosity. Remember, viscosity is how it resists flow. The more viscous, the thicker it is. Matter's properties can be surprising, especially with non-Newtonian fluids. These special substances act like both liquids and solids depending on the force used. Can you think of other examples of non-Newtonian fluids you might see in your everyday life? This video brought to you by Kimberly Scott Science. Check out the video description for the corresponding reading passage, lesson activities, and a hands-on exploration.